Hi, and welcome to today's episode. As we have seen so far, AI can affect every part of our society. AI systems help us in a lot of situations, like optimizing energy consumption or assisting us with our daily tasks. AI systems also make far-reaching decisions, like when to brake in an autonomous car or whom to give a credit. But with great power comes great responsibility. So today we want to learn more about the impact of AI on our society and the challenges that come with that. To begin, close your eyes and picture a doctor. Did you picture someone like him? Or someone like him? Or maybe have you pictured someone like her? Our view is sometimes biased towards specific experience we had in our life. And with the usage of algorithms, we generally hope to make fair and objective decisions based on facts that, in contrast to our human decisions, are not influenced by emotions, moods, or one-sided experiences. Nevertheless, in the media we read about racist chatbots, AI making wrongful convictions, and sexist face recognition systems. With our knowledge about AI, let's take a closer look at those examples where we have a mismatch between expectations or hopes and reality. Somewhat similar to topic modeling, where we clustered similar text documents, we can analyze single words. Word embeddings is a technique in natural language processing where words are embedded in a high-dimensional space. By analyzing the context, in the sense of the surrounding words, for each word in a text document, with this we can compute for a given word how close to or far from other words it is. Very simplified, normally we have about 300 dimensions instead of those two, visualization works like this. We have words such as dog, which are close to puppy, doggy, canine, or pet, and rather distant to words like cat. This allows us to learn analogies such as dog as to puppy, as cat is to X, with X most probably resulting in kitten. Or slow is to slower, as fast is to X. Or Paris is to France, as Berlin is to X, and so on. We can use word embeddings, for example, for translation, sentiment analysis, such as positive or negative emotion, paraphrasing, and text summarization, and so on. If you want to learn more about word embeddings and see a full visualization for your language, see the additional course material. As always with machine learning, we need a lot of data to learn those word embeddings. A standard approach for this is to crawl the web for billions of text. So let's see what we get if we want to find an analogy for man is to doctor as woman is to X with such a fully trained word embedding model. We get nurse. Or if we use male is to programmer as female is to X, we would end up with homemaker. Well, naturally, the word programmer or doctor itself is neutral to gender. But our word embedding algorithm learned from the documents and websites it analyzed to see doctor closer with male than female. Our social perception of this job, the perception we have, our human bias, is reflected in the language we use and the text we write. Let's have a look at another example. Remember our monkey game from some units ago, where we needed to decide if a monkey bites or not? We developed the following model to classify whether a monkey is biting or not, which worked out pretty well for the monkey from our test data. But how would we classify this? Well, According to our rules, we would most probably classify the crocodile as non-biting, as it is not smiling and has no eyes. This could be a grave mistake. Once more, our data is biased, as it might not represent the animals in our zoo very well. This is exactly why some of the face recognition systems are reported racist or sexist. They were only or most predominantly trained with Caucasian men. So we see that AI is not fair, although we hope for better, more objective decisions based purely on facts. Well, the algorithms, and therefore the AI itself, is not discriminating, sexist, or racist. But we humans are biased. And so is our data. The data we feed into our machine learning algorithms. When we use the data we generate for machine learning, we transfer our human biases to the technology. And for all those problems, there are technological solutions. But we need to be aware of biased data and address this. For example, this becomes a problem when we use AI to assess which person to hire, which a lot of companies are doing nowadays. As AI is making decisions based on old hirings, it learns out of those hiring which might have been biased. If a tool for filtering applications is trained with data based on people's past decisions, the machine learning algorithm might also learn to discriminate against women or people with a particular ethnic background. This can even happen if ethnicity or gender has been excluded from the dataset in advance. The algorithm may be able to extract the relevant information from the name or address of the applicant. There are numerous cases of AI used for hiring having exactly these problems. The problem with biased data, for example, applied in hiring, leads to our next point. If machines are making decisions about human lives, we kind of want to know why and on which criteria. For example, the acceptance or non-acceptance for our application was decided. This way, we can identify such a bias. And as another example, if AI systems are used to determine whether or not we obtain a loan, we would like to know why we aren't creditworthy. The European General Data Protection Regulation, GDPR, which has been enforced since 2018, sets out strict criteria. According to it, serious decisions about our lives must not be made by machines alone. And when using algorithms, consumers have a right to meaningful information about the logic involved. But we have seen neural networks, a technology that is used very often in practice. And we have also seen how difficult or almost impossible it is to comprehend the decisions of these networks, because the millions of parameters are difficult to understand. This is why there are approaches that aim at explaining the decisions made by an AI, so that it doesn't remain a black box. Those approaches are referred to as explainable AI. Explaining a decision is something different than transparency. Transparency means that the behavior of the application is fully traceable. In practice, however, this requirement is difficult to meet, since, as we saw, most models are necessarily very complex. Explainability means that for a particular individual decision, the essential influencing factors can be shown, which is sufficient in the sense of the European General Data Protection Regulation. In our example of obtaining a loan, explainability could mean something like, if you would earn 45,000 euros instead of 30,000 a year, you would have been classified as creditworthy for a loan with this amount. If we use AI in more and more use cases and let them make decisions in situations affecting our health and life, such as autonomous cars, it's very important for us that we can rely on those decisions. This means that we don't have to fear that AI systems will fail, even if there are only small changes in the input. One of the most famous examples is related to autonomous driving. Let's have a look at those two signs. The speed limit one is obviously 35 miles per hour, and then we have a normal stop sign with some stickers on it. Or is it? Let's ask an AI. Okay, it recognizes the speed limit as 85 miles per hour. That's scary, but somewhat understandable. We humans might misclassify this slightly modified sign at night with bad light and so on as well. The same way this might pose a problem for camera sensors in an autonomous car. But how about the stop sign? Wait, what? It is recognized as a 45 miles per hour speed limit sign? Let's have a look at a similar example to understand how researchers were able to trick the AI. To do this, they didn't even need access to the data, internal structure of the model and so on, which we would call a white box attack, but just experiment with the model from an outside perspective, which we call a black box attack. And these types of attacks are called adversarial attacks. Given an AI that classifies different animals, well, let's take a picture that is correctly classified as a panda. As you remember from last week, images are represented by pixels. And for example, the respective red, green and blue values for each pixel. We could now try to change pixel after pixel just a bit. For example, adjust the red value and see how the model reacts. Is the image still recognized correctly? Or have we already been successful in tricking the AI? In the end, after letting the computer experiment a lot, we get a pattern of small changes for each pixel that we can apply on our original image. Although we as humans see no difference between the original and the modified picture, we now have a completely different classification. The same way, we can compute the rather unsuspicious pattern of putting stickers on the stop sign that lead to a wrong classification. As the stickers on the stop sign have a much smaller area to work with than the pixel patterns for the images of the panda, the perturbations they create have to be more significant to trick the AI. But nevertheless, they seem unsuspicious and might just be some random graffiti. So once more, we see that machines are not focusing on the same features of an object as we as humans would do. We humans classify a panda by its 4 legs, the fur, and so on, while an AI might focus on some, to us humans, strange and rather arbitrary patterns in the pixels of the image, with no clear reference to the actual object. And this we can use to trick the AI. It's more than safe to assume that current self-driving cars wouldn't fall for the stop signs we saw. They are trained with millions of stop signs under different circumstances and explicitly with adversarial training, so testing and training the models with data with such perturbations, so that they generalize more robustly in the field. Nevertheless, it's probably not safe to assume that attacks like these won't ever work. As with traditional software, we constantly have to test and improve our algorithms for the best security. In particular, when computers are making decisions that immediately impact our lives. And remember the unit on Can Machines Think? There is nothing like malice computers over which we have lost control that try to hurt us on purpose. To conclude today's topic, let's have a look at examples how AI will impact our society. We learned a lot about what AI is capable nowadays in the last few weeks. AI is able to some degree to write news articles for certain topics such as sports, and AI can even live ticker sports, just based on the current statistics such as ball possession and so on. AI can do some manufacturing jobs better, faster, and more reliable than we humans can. AI can drive more secure than we humans can, and so on. Artificial intelligence can automate more and more jobs, which so far, if you remember our definition from the beginning of this course, required human intelligence. So yes, AI and the digital transformation will change how we work, communicate, and live. But we have learned in this course that they won't supersede us humans. We learned that AI can excel us humans at certain tasks, but not more than this. It's similar to an excavator. An excavator can dig better than any human will ever can, but not more than this. So, what have we learned regarding the influence of AI now that we understand the ideas and principles behind this? We saw that software and AI cannot have moral or ethics. But AI can discriminate or be tricked. It is not automatically fairer, more transparent, or more secure than our human decisions. If we use AI system for tasks with social relevance that impact our health, our life, and so on, we have to consider things such as biased data that might lead to discrimination. We have to take measures to make the decisions of AI systems explainable. And we have to build AI systems in a robust way. These are algorithmic problems that can be solved. And many more of the challenges we face with AI are not that different to challenges we face with traditional software for similar use cases. Such software has to be tested thoroughly to ensure that it works as intended as well. When it comes to the discussion of exactly where to apply AI and where not, it's in the end the same as with other tools. We humans can use them in a more or less ethical way. In this course, we learned about the fundamental principles and ideas of AI. This enables us to evaluate possibilities and limits. And with this knowledge, we can actively shape AI systems and their influence on our society. We hope you gained a better understanding of what AI is, how symbolic AI and machine learning works, if machines can really think, and how AI affects our daily lives and our society. If you want to learn more, we recommend you read our What's Next section, or stay tuned on computingeducation.de. And if you are an educator or otherwise interested, we prepared an additional video where we give hints on how to teach AI. So, thank you for traveling with us through the world of AI. We hope we will see you soon on our next journey through the fascinating world of computing.